Hi, Chris Good here, and we're back with one more mechanism in the hallucinogens category. We talked about more hallucinogens than just these few that I'm reviewing here, but these are the ones that I'd like you to focus on when you're preparing for this next test and thinking about how these drugs actually work in the synapse. So there is a class of hallucinogens that we talked about called the anticholinergics. And by the name, you might think, oh, well, they do something with acetylcholine receptor. And that's exactly correct. So normally you would have a postsynaptic receptor for acetylcholine. And this is like some of the very first receptors we talked about. When acetylcholine binds to it, right, there's sodium ions that come into the cell. But that's not the type of acetylcholine receptor that we're talking about when we do talk about the anticholinergics. There's another kind of acetylcholine receptor. You might remember the first kind is nicotinic because nicotine sticks to it pretty well. This one's different. This one is called a muscarinic acetylcholine receptor, right? So muscarinic, and you want to guess why? It's because there's a drug called muscarin that activates this receptor. So this is a muscarinic acetylcholine receptor. And normally, acetylcholine binds to it and activates it. And you might recognize my little cartoon drawing of this being a G protein coupled receptor because it has a G protein on the inside of the cell that comes off when acetylcholine binds to it. Normally, acetylcholine is packaged into these vesicles and it's released and it binds postsynaptically. And these receptors are found in lots of different parts of the brain, but also on smooth muscle, like the muscles that are used to constrict your pupil during the pupillary reflex. Well, as luck would have it, there are these drugs that are anticholinergic and they block acetylcholine receptor. But these drugs, the ones that are the hallucinogens, block the muscarinic type of acetylcholine receptor. So we can call these drugs muscarinic acetylcholine receptor antagonists. We abbreviate acetylcholine ACH and receptor R. They're antagonist because they block the receptor and they prevent acetylcholine from binding to it. So go away, acetylcholine. And these are drugs that we talked about, like atropine, named after the fate Atropos, who cuts the thread of life. We also talked about one called L-hyoscyanin, and scopolamine is the other one. Also used as a anti-motion sickness drug. All of these drugs block the muscarinic acetylcholine receptor, and therefore they are muscarinic acetylcholine receptor antagonists.